been a minute, y'all. It's about to be fun, though. We got Markus in the building. Tyler. It's mean, man.
It's an initiative to create tradable, decentralized financial derivatives. Kind of a mouthful. We've created a protocol for financial derivatives on Stellar's platform using their smart contract solution. So we use their pre-authorized, time-bound, and their signer systems to create a trust-free financial derivative stored totally on ledger. This allows us to get rid of the multiple middlemen involved in the financial derivative scene and makes the derivatives much more efficient. I think our derivatives are 12,500 times more efficient than the current incumbent derivatives. We can support any asset that's anchored on Stellar's platform, and anybody with an internet connection can theoretically use our solution as anybody with an internet connection can use Stellar's ledger. So I'm really excited about this product, and I think it has a lot of potential, especially given that Stellar is currently at an inflection point when it comes to becoming a global payment platform.
What's going on, everybody? It is a beautiful Wednesday, and I'm excited. We're going to talk smart contracts today. That's definitely the talk of the town. Stellar has a lot of great capabilities, and I really do see this as something that can absolutely, take it to the next level without a doubt. Before we jump into it, I want to give a quick shout out. Oh man, look at this from Siberia. What's up, man? Crypto Trip. What's going on, baby? Glad you can make it. Glad everybody out there can make it. It's going to be a great week. Tomorrow, Thursday, I've got Mike Kennedy, CEO of Velo Labs, and I'm really excited for this one. The Southeast Asian market is going to be huge. Mike Kennedy co-founded Zelle, which is the number one payment app in America. And we all hear about PayPal, Cash App. This is number one. You understand me? They've been working with banks. That's what they specialized in. And he chose to join blockchain and get involved with Stellar. And he's now the CEO of Velo Labs, who's going to be utilizing the Stellar network. So that's going to be a great chat. And also we have coming up the Jordan Edelstein, the Chief Marketing Officer of Stellar Development Foundation. That's going to be Wednesday, 3:31. That's next week, 12:30. Don't miss it. Listen, do not sleep on what Stellar is doing. If you're sleeping, if you look at your neighbor and they're sleeping on Stellar, tell him to wake up. Shout out to Harold, my man. He's out here, Dominican Republic representing. Shout out to the entire Stellar Global family. I know Amir's out there. Stellar Turkey, Bora, what's up? Stellar Ireland, Fergal, what's up? We got Austria. You got Stellar Korea, man. Stellar Korea is huge. What's up to everybody out there? Stellar Caribbean. Dorian, what's going on out there? To everybody out there. Larry, what's up? Out there in Stellar Caribbean as well. So really happy. But we are going to jump into this right now. DeFi, smart contracts. I'm about to bring on two individuals who I have a lot of respect for. These guys are smart. They're hard worker. And they got that toughness in them, man. You could just tell. It just comes through. And those are the type of people you want building on your platform. Everybody, welcome to the stage. We've got Markus Paulson Luna, CEO of OptionBlox, and we have Tyler Vanderhoeven of Stellar Development Foundation. Round of applause for release. Hey, what's going on, guys? How's everybody doing today?
Hey, everybody. Good. Good.
Doing fantastic. Good to be here.
Excited for this. Should be fun.
It's really interesting. I was really looking into the beginnings of the smart contract journey, And I thought it was really interesting that a computer scientist by the name of Nick Szabos first proposed it back in 1994. Now, what's insane to me is that back in 1994, he actually invented a virtual currency called BitGold in 1998. This was 10 years before Bitcoin was even created. So that kind of stuff blows my mind. Just, it makes me wonder, how far-sighting, everybody was back then, and how everything that we're seeing now is really just an old concept. But it really makes me excited for the next 10 years because I wonder what concepts are being introduced today that are going to be common in the future to come. So, Tyler, I just want to start off with you, man. Let's start off and let's get a foundation here. So we know smart contracts. We hear the term smart contracts. When you first started mentioning it coming to Stellar, this was sometime March or April of last year, you used the term Turing signing servers, TSS. What the hell does that mean, man? Explain that to us.
Sure. So I think when I first got started, it was just this idea of how do we programmatically create a transaction, and the word smart contract is just so loaded. You ask 100 different people, what does it mean? You get 100 different answers, and so particularly in programming, terminology is so incredibly important, and it's rather I'd rather be verbose than trendy, and really try and get across the meaning and avoid any confusion, automatic confusion before we've even had a chance to describe what it is we're trying to do. So I think because the smart contract term is so loaded and misunderstood or understood in different ways, it was important to kind of move away and move towards a functional terminology, which to me was more, we're trying to program transaction creation. And even the Turing part isn't super important. It's not the most important part of what we're trying to do. But the idea of programmability, it is a smart contract, but what that means is going to be a lot of different things. Essentially, all a smart contract is taking something that's repetitive or requires human intervention and turning that into automation through a computer, so that something that needs to be very secure can be done without a lot of or any human interaction by setting it up to be programmatic. And if you break it down to that very base terminology, you can use different product terms or definitions, but ultimately all you're trying to do is add automation to functions that need to be secure. And once you accomplish that, you open up a whole world of opportunities. And originally, that's what I was trying to do, and it's neat to see that actually happening.
Cool. And I'm excited as well. So here's a question. So Stellar currently has the capability of doing smart contracts. That was something I remember in the very beginning. Can't we do smart contracts? But when you actually look down into it, you can do smart contracts on Stellar currently, but there's several constraints. Could you maybe elaborate some of the constraints that Stellar does allow in regards to smart contracts currently?
Sure. So the idea of Turing completeness or accomplishing any programmatic logic, which is native to like an Ethereum blockchain with the virtual machines, is completely foreign to Stellar. And that's very intentional. Stellar is not Turing complete. You don't have programming languages you can use, but you do have a large collection of very flexible and powerful operations, but they are limited in what you can do. And so anything you can sort of cobble together with operations, there's all kinds of interesting logic you can do between time bounds and multisig and combining, because it's an atomic swap where the whole transaction and all the operations within it succeed or fail within the same execution. There's all kinds of really interesting things you can get away with. But at the end of the day, that transaction still needs to be signed and created. So that creation of the transaction and then the signing of that transaction still has to happen at some centralized level right now. So even though there's a lot of smart things you can do with that, there's still these limitations around getting that transaction signed by multiple parties, particularly if it's that multi-sig scenario. But then even actually creating those transactions in any sort of repetitive format, you're going to have some centralized server to do that. And so the idea of the Turing signing server is to remove those two constraints where you're still using, at the end of the day, it's still Stellar transactions. It's still limiting the capabilities within those operations that are already natively available. What we're adding is this layer 2 on top, which creates those transactions in a decentralized way. So you don't have a centralized server that can all of a sudden just go down, and now these transactions can't get created, or really, and more importantly, we're decentralizing the signing of those transactions. So I can set up an account and safely delegate the signing power of that account to multiple third parties through some arbitrary function that says, I promise that I will always sign transactions from this account so long as it follows the pattern of X function, whatever that, we call them TX transaction functions. That's kind of the smart contract piece. And that's really powerful, but there's nothing really non-Stellar about it. Like, you're still using Stellar operations, you're still using Stellar transactions. It's just adding that second layer of creating and then signing those things and moving that into the decentralized world.
Man, we love hearing that. Still using Stellar. That's right. We want to make sure we're using Stellar, and I'm glad to hear that. You mentioned Ethereum. So Ethereum, they allow smart contracts that are written, deployed, and executed on chain with the same request. And so I've been trying to really understand some of the advantages with what you guys are doing. And so, if am I correct, there's the way that Ethereum is handling their smart contracts all within one request, that there's some potential flaws and drawbacks of that. Am I correct on that? Can you maybe help me out in understanding this?
Sure. So I don't think I'd jump right to it being a flaw. It's just a different design decision that those things are happening together, where the transaction is both created and executed within the same code block. There are some tremendous benefits to that, particularly when it comes to actually getting data moving around, because you have access to the database directly, so you don't have to make external fetch calls. We're already seeing some issues with that, with the need to pull in external data from Ethereum, where you start to approach things like the link blockchain and oracles as you pull in data. So that's still a problem where you have to pull data in. There are some pretty significant benefits, but the one big problem that you're going to run into again and again is that it's going to be slower and more expensive, because you're running both of those necessary functions in parallel together every single time. So there is significant benefit both on the cost and the speed side of things to have those things separate, and really answering the question, what needs to be secured, what needs to be run on chain, what needs to be immutable and auditable. Is it the balance shifts, the value transfer, the asset transfer, or is it also the code execution? And the answer may be yes, they're both important at some levels, but particularly in the Stellar use case where you're focusing primarily on value transfer, the actual code execution is not as important. So long as the XDR, so long as the transaction that's created at the end of the day follows some code patterns and is enforced through TX functions, through these functions, and you're relying on the multi-sig scenario, you're relying on multiple third parties to execute the same code and arrive at the same XDR, you have some level of assurance that even, like, worst case scenario, somebody out there is running bad code that's altering it has to, at the end of the day, for it to be malicious, it has to alter the XDR state. And once that XDR state is altered, the signature is no longer valid. And so you get this inbuilt security through multi-sig that allows this separation of transaction creation and transaction execution, where you get all the benefits and speed and cost of Stellar while still getting the smart contract functionality, the Turing completeness of Ethereum, by having these two sort of parallel networks running, where you get the benefits of both without any real significant compromise, so long as that use case revolves more around value transfer and less arbitrary computation.
So a quicker, safer contract. So go ahead, Markus.
Yeah, if I can jump in quick, just on that topic. One thing that I found really interesting was that if you guys have heard of rollups on Ethereum, they're a layer 2 solution that Ethereum is trying to use to fix some of the speed and efficiency issues of their blockchain. Those have their own limitations, but a large part of the reason that they're doing that is because they want to move that code execution off of the main chain because it makes the main chain so much less efficient. So they've even realized that issue with their smart contract solution and are trying to figure out ways to work around it. So one of the things that I love about Turing signing servers is it's being built from the ground up, trying to avoid running into that issue and keeping the code execution in a place where it makes sense and isn't going to bog down the entire chain.
Wow. And that kind of answers a question I was going to ask you later on was, are we too late to the smart contract game? Is it too late? Is it everything too far advanced that Stellar is too late to the party? Based on what you're saying, I'm going to let you answer that question, Markus. Are we too late to the party?
I'd say absolutely not. There's a lot of issues with Ethereum's smart contract engine, mostly efficiency. But then there are also a few security issues just when it comes to your transaction execution is decentralized. So you don't actually have a way of checking your transaction before you submit it to the ledger. It's going to submit no matter what, whether or not you're happy with the outcome of that smart contract. But then on top of that, I think Stellar as a blockchain is set up much better than pretty much any other blockchain I'm aware of for issuing traditional assets. They've got great account asset controls with all of the different account flags you can set, where you can force holders to have certain authorizations to be able to hold an account, hold an asset, and that'll enable you to build KYC into your blockchain service. They also just added clawbacks, which allows you to pull back assets that were maybe sent fraudulently or sent somewhere they shouldn't have been. So, I mean, if you combine all of that, it allows companies to issue equities on Stellar like DSTOQ is, or build mutual funds like Franklin Templeton is. So if you take the traditional financial assets and then combine them with everything that's going on in DeFi, with the crazy amount of capital efficiency that DeFi offers, you have a really, really powerful solution. And I think that's what Stellar, when you combine it with Turing signing servers, is offering.
Wow, man. That's awesome. Shout out to Crypto Trip out there representing Russia. It says a lot of people out there supporting. We appreciate you tuning in for the show today. Tyler, back to you in the beginning. When did you first start working on it, right? It was around March or April of last year. You had mentioned that Stellar was missing decentralized transaction creation. What did you mean by this?
So I was keeping an eye, like I just joined Stellar not too long before I really started ruminating on this idea and templating some ideas. Somebody was in the Keybase and was asking like, hey, I've got this donation pool where people are sending money into it, and we have to guarantee that the distribution of these funds is following some pattern, but people don't trust me to just send tons of money to an account that I own. And so I
wouldn't trust them either.
That seems like a reasonable request. Like, how can we sort of give shared ownership? We have these mechanisms built in. It's called multi-sig. But the issue is all of those multi-sig still rely on people, some human to say yes or no to something. And what if there's malicious intent? Like you think of, I love to play video games, and we might do like wagers occasionally. And okay, yeah, sure, we don't have to trust the main account, but there still has to be some consensus. And if there's too much colluding going on, or, Ricky's like, you may have won, but I don't care. I'm not sending the money. I'm not signing this transaction. You're still involving humans in this process. And that doesn't seem good. I would like, it doesn't seem necessary. And so I started templating an idea of how do we safely distribute ownership of an account in a programmatic way to where machines own signing power over accounts rather than humans. And it was actually really hard to do because you've got a secret key, and nobody can have that secret key at one time. And so, yeah, you've got multi-sig, but now you've got to kind of give ownership of this. And what's the incentive model? Like you give it to somebody else and they've got a fifth ownership, but if they don't have an incentive to actually sign transactions, and then you've got the whole issue of how do you ensure that the transaction coming in is actually legitimate? And then you've got signature coordination so that you ensure that everybody's executing the exact same logic so that the output XDR matches, so that when they sign, all the signatures match and you can actually execute to the blockchain. What do we actually need? Is it creation? Is it submission? Is it storage? And so just started experimenting, building a lot of prototypes and ideas, and eventually landed on a really early reference implementation, and have just kind of been iterating on that progressively as people recognize this is something that is powerful and is useful and is necessary in many ways, to be able to programmatically have signing power over an account. And it's just kind of gone from there in fine tuning all of those points that I've talked about, the fee structure, and what do we actually need out of this? Is it storage, or is it submission, or just creation and signing, and coming up with, at the end of the day, trying to land on some protocol, some official version of whatever this TSS thing is, so that we can all agree and start bootstrapping a network that kind of achieves the dream of what we originally had of trying to hand over ownership of an account in a secure, decentralized way.
Nice. And you kind of started this off, as a personal project. And at what point did SDF turn around and said, "Yeah, you got something going on here. Let's put some support behind this"? About what was it, close towards the end of the fourth quarter?
Sort of. So, I mean, the way the SDF supports a lot of these things tends to be more community driven. So as you start to build things out, it's share it with the community and get community interest. And so a lot of the energy behind SDF showing interest in TSS is more going to be maybe in like experimental infrastructure grants, or really, I mean, like, I work for SDF and I've been given a lot of freedom and time to work on this and put effort behind it and share it and show up on shows and talk about it. So a lot of the support has been in those arenas, as well as just the research around what does the community need? Like, what are people actually building, to see there's no real one perfect solution for these things. It's always iterative. And so you never land on a product as a solution, you land on protocols as solutions and then build products around those. And so TSS, the reference implementation, is more of a product. And so you might work on that and try and get that built up, but it's still a lot more work around reference implementation. So a lot of the support is going to be just spending time in meetings and supporting other ecosystem participants in standing up nodes or standing up the Turing signing server network, and then seeing those things grow and putting support into projects that are being built on top of that, as opposed to maybe like a direct, like SDF doesn't stand up its own Turing signing network. That's not kind of the direction we want to go. We want it, if this is valuable, if this is something that the ecosystem needs, it needs to be something that the ecosystem leads and produces and puts all their energy and effort in. Like, we want this thing to exist. And I think that's a really, really good direction to have, where these things aren't propped up, they're built up by legitimate business use cases.
Nice. And one person is Markus. And I started off the live today with a throwback. Do you remember that day, man? That was Meridian 2019, Mexico City. I think I was down in the front row recording everything. And now look at you, man.
Yeah. I remember that. That was a fun conference.
It was. I can't wait to the next live one, everybody. I want to say, man, I always do some digging before I do things, and I've noticed that you were around for a long time. You actually, looks like you wrote this. Let me see, get this all together here. You have wrote a paper. The financial derivative ecosystem is old. Decentralized ledger technology is its fountain of youth. You remember when you wrote this piece?
Yeah, I wrote that senior year of college. It was after I'd been working on OptionBlox, which is our decentralized financial derivative product, for about a year. And I decided that this seems like a really valuable idea. I want to try and publish something around it to kind of verify a lot of my findings and a lot of what I was thinking in that respect, because the derivatives ecosystem in traditional finance is really incredibly inefficient. Like, it's crazy. Every derivative, like option or future that someone buys or sells, has 4 to 5 middlemen, and they're all taking a little bit of the profits that come from the ecosystem. So investors really are not very well served. I mean, they're well served, but they're served in a very inefficient way by the ecosystem. And so blockchain technology ends up being a really valuable technology there, because you can, by taking all of those verifications that are necessary in the derivatives ecosystem and putting them on a chain where everything is by definition trustworthy and immutable, you can get rid of like almost all of those middlemen and make the ecosystem significantly more efficient. So realizing all of that, I decided to actually go and do some research. So I spent around a semester working with one of my professors to really test out all my ideas and find supporting evidence, and eventually ended up mapping out this research paper, which lays out why the derivatives ecosystem is so inefficient and how blockchain can fix that, and then why that's actually important. And we found pretty much what I expected, which is the average cost to process a derivative in the traditional financial ecosystem is like 72 cents, whereas doing it on Stellar will cost you less than 1,000th of a cent. So huge cost efficiency.
Wow.
And then on top of that, that's also super valuable because derivatives are really valuable for global economic growth. They help make markets efficient. They give businesses access to capital and allow businesses to hedge their investments. And on top of that, a large amount of the world doesn't actually have good access to financial derivatives. So if we can take the financial derivative ecosystem, make it more accessible, make it cheaper, allow it to serve a lot of developing countries, you're all of a sudden bootstrapping a whole lot of economic growth all over the globe as long as you make it easy to use. So yeah, I wrote this paper, ended up getting it published and presented it last year. So it was a lot of fun. And
Markus. You did this in college. Well, hold on. First of all, round of applause for Markus. Now, listen. I know what I was doing in college. I wasn't writing derivatives paper. How did you even get into, how did it even enter your consciousness as a senior in college to even attack this?
I mean, yeah, it all just started because I was trying to build OptionBlox, and I guess that started because one of my friends one day said, "Hey, blockchain's pretty cool. We should try and do something with it, just for fun." So we started looking at projects we could do on blockchain, and I landed on derivatives and decided that it was actually super valuable. So I should try to build something with it. And I mean, the blockchain industry, I think, is not super difficult to get involved in as a young person because the industry overall is pretty young. So people don't really look at you and say, "Oh, you're 22 years old. Why are you trying to do this?" They look at you and say, "Oh, you're interested in this new field. That's cool. What can you do in it?" So
right.
Yeah, it ended up being a super fun project. I really enjoy building protocols on blockchain, so it kept my interest and I kept working on it.
And what I think is really cool, man, is so you were a college student. You did your own research. You found out about all these different blockchain protocols. You discovered Stellar on your own, right? Mm-hmm. And started building. I get asked asked a lot of time, why do I do these interviews? Why do I spread the word? It's to me, it's a very important time in our lives, and that people like yourself are able to do this and to hopefully inspire the next builder, the next developer to do the same thing. So, I mean, hats off to you for taking that initiative. Very impressive. It ended up getting you to Meridian stage, and now you've got actually a product here that I'm hoping, if you don't mind, you can share a little bit about how you're utilizing this Turing signing server with Stellar here that they're putting together. I know you've been a real big part of all these things that have been happening. And I just wanted to ask you real quick. I mean, you talked about Ethereum as another option in some of the different issues. Have you ever thought about other protocols even besides Ethereum to utilize? I know that there's Polkadot and others that are out there as well.
Yeah, I've definitely thought about those, especially when I was building this, because Polkadot was around even back when I started building all this, and a lot of it came back to the capability to issue real world assets on the blockchain.
Okay.
So Stellar is well set up for that. On top of that, you also want to have a blockchain that people actually use and is pretty flexible. And Stellar was, when we started building, Stellar was one of the most popular blockchains. It's still one of the most popular blockchains. I think it's only behind Ethereum and Bitcoin in terms of volume of transactions actually done on the ledger.
Nice.
And
Nice.
a lot of those.
Say that one more time. Say that one more time. It's only behind Ethereum and Bitcoin.
Ethereum
and
Bitcoin.
as far as wow, yeah, that's pretty big.
Transactions. So it's, even though it's not like the most popular one out there or the most hyped one out there, it's people are actually using it like every day. And so I looked at that, and on top of that, a lot of the other smart contract solutions are either built based on Ethereum's virtual machine, which, as we discussed earlier, has a lot of inefficiency issues, or they aren't actually that flexible. They're either built by some third party or centralized, or you can't actually do a whole lot of things with them. So since we needed a really flexible one so we could create derivative contracts, we decided to go with Stellar. And yeah.
Okay. Interesting. So I'd ask you earlier, are you able to maybe share your screen a little bit and show kind of what you've been working on? All right, give me 1 second.
You have a presentation that I can take you through.
Okay, perfect.
Awesome. So the organization that I represent and I'm the CEO of is called Script3, and we have two protocols that we're currently developing called OptionBlox and YieldBlox. OptionBlox is the decentralized derivatives protocol that I've talked about a bit, and then YieldBlox is a decentralized lending protocol. So I'm sure you guys have, and much of the audience has heard of Compound and DYDX. Yes. Those are lending protocols on Ethereum. We're taking a lot of what they do and bringing it over to Stellar, so people will be able to lend their Lumens, lend their Stellar USDC, lend their Stellar-based Bitcoin in YieldBlox. Other people will be able to borrow them, and the lenders will receive interest fees on those assets that they're lending. So I'll take you guys through a brief explanation of the protocols and answer any of the questions you have.
Perfect.
There we go. I'll skip some of this because we've already talked about it. But yeah, let's just start off with OptionBlox because that's what I've spent the most time on, been building it for years, and I know it very well. But basically, there are three key points that OptionBlox offers over traditional financial services. So this is taking your derivatives on OptionBlox and comparing them to an option that you would buy on Charles Schwab or Robinhood. The overall cost of writing an option on OptionBlox, and so writing, trading, and executing is going to be less than 1 cent, much less than 1 cent actually. Whereas in traditional financial services, you're going to be charged 72.5 cents. You won't actually be charged it, but the exchanges will sell your data and use other revenue sources that would be owned by you in a decentralized ecosystem to generate those 72.5 cents. There's also increased flexibility. You can use any asset that can be anchored on Stellar, which is pretty much any asset in these derivatives. And there's greater transparency because all transaction data is stored on Stellar's ledger and is accessible in real time. So if you compare that to traditional financial services, sharing data is actually a huge issue there. It's super expensive and time consuming, and it's a big headache for regulators. So I honestly think that going forward, a derivatives ecosystem and a DeFi ecosystem built on a blockchain like Stellar is going to make regulators' lives a lot easier. So hopefully they'll recognize that at some point. But if we go through our actual solution stack and how we're using Turing signing servers, we broke our product into two parts. We have a web app which allows users to easily interact with the Turing signing servers. So users can hop on our website, they'll link their wallet to our website, and then they can go through and decide what they want to do. If they want to write an option, there will be buttons that allow them to write an option, or they can buy options, or they could execute options they already own. So we own this website and maintain it. But users will input a command, and then that'll get sent to the Turing signing server protocol that will have stood up by then. So that protocol will hold multiple TX functions, like a TX function that writes an option for you, or a TX function that executes an option, or settles an option. And we'll ping the correct TX function. It'll intake that command. It will generate a Stellar transaction, sign it, and send it back to the website. the website will then go ahead and send that transaction XDR to the user's wallet where they can sign it. They'll return it to the website, and then we submit it to the Stellar network. And then voila, you have a written derivative or an executed derivative, whatever you wanted. So the Turing signing server protocol, we don't own or control it. We develop it, push it up to the Turing signing server network. But at that point, we don't have any control over it. That's how you know it's trustworthy. And all of your transactions are going to be carried out by a contract that we don't actually own or control. It's something that you can see and is completely safe and immutable. So to actually update that protocol, we have a decentralized governance model where OBX token holders can vote on protocol changes or updates. So to dive in a bit more, users would come into our website. They would select a option that they wanted to write. They would send their request to the TSS protocol. The TSS protocol carries out the request. The request gets sent to Stellar, and then the user receives an option token. And that option token would be like a Bitcoin call option. So that would give the user the option to purchase Bitcoin at a certain price. They can then trade that option on Stellar's DEX with other users because the option to purchase Bitcoin at a certain price has some value. For instance, if I have the option to purchase one Bitcoin for $40,000 at any point in time until that option expires, that option is obviously significantly valuable because Bitcoin's worth a lot more than $40,000 right now, right?
Now, wait, Marcus, wait 1 quick second. Now, one thing that you said, now you mentioned this example, Bitcoin, but earlier you mentioned that one key factor with Stellar was the availability to have real world assets. So are we discussing here that this would allow you to maybe tie into, let's say, D stock and utilize a stock or any other real world assets, that's out there on the Stellar DEX?
Absolutely.
Wow.
So yeah, you could write Tesla call options or Tesla put options or Apple call options, anything that's supported on the ledger. So yeah, the possibilities are really infinite. One of my favorite ones is I'd love to see Stellar or someone use Stellar to build a carbon credits market, because then you could write derivatives with carbon credits. And that would be incredibly valuable for the carbon credit trading ecosystem.
That's huge. That's huge. Somebody listen up right now and make that happen.
Yeah, and then commodities too. So farmers could use these to write futures on their crops or buy futures on their crops, which would be huge in developing countries where they don't necessarily have access to a futures market, but futures are still really important in farming. But yeah, any way to round this out, you can trade your option, and then once that option expires or you want to execute it, you then go back to our website and use it to ping our Turing signing server protocol, and the protocol will then build a transaction that executes the option according to the parameters specified in the contract. One important thing to note is users don't actually have to use our website to interact with the Turing signing server protocol, because that would make it centralized if you had to go through a website. A user could just send raw calls to the Turing signing server protocol from their computer, or they could use someone else's website that they set up to use our Turing signing server protocol. So it's usable from anywhere, really.
I'm gonna just jump in here real quick and say that that's huge. That's something that we haven't really seen ever, is the service really completely separated from the interface that you interact with it with. Like that's incredible. Anybody could take the API calls, particularly like translation work. Like if you wanted this service to become available maybe with different primary assets in a different language, someone could just take all those APIs, wrap it in a new website, and have the exact same functionality. That's insane to me.
Insane is definitely the word that I would use. Man, this is big. You're talking big talk right here, baby. All right, continue, Marcus. Go ahead.
One more thing to hop onto Tyler's point. One other thing that I really like about that is it's possible for other businesses to build our service into their websites and services really easily. So if Robinhood all of a sudden wanted to start offering options written with OptionBlox, they could just build it into their app, and it'll be super easy. So yeah, really exciting stuff.
Robinhood, we're talking to you. Robinhood. You know you need it. Let's go.
They
All right.
So yeah, then jumping into our second protocol, we're actually planning on launching this protocol first because we think it's very important for building liquidity on the DEX. But it's called YieldBlox. It's decentralized lending. I talked about it a little bit earlier. But so we compare this one to lending protocols on Ethereum because lending protocols on Ethereum, as we know, are extremely popular. So I think a direct comparison there is pretty relevant. But basically, we take the costs of Ethereum lending platforms and basically just erase them. It costs us less than 1/10 of a cent to process any loan with YieldBlox, whereas it costs more than $70 to process a loan in Ethereum. If you want to go supply your money for lending and compound, it's going to cost you $70 to $80. Yeah, and we think that that's really, really bad for financial inclusion. If someone doesn't have thousands and thousands of dollars to deposit, it doesn't make any economic sense for them to actually deposit their money in a lending protocol. If you have $700 that you want to deposit, and you're going to eat a 10% cost just by depositing it, and then you have to let it sit there for maybe years before you even recoup that initial cost. So YieldBlox also is much more accessible than traditional DeFi loan applications. This is mostly a function of the cost. Transaction fees won't actually prohibit users with less capital from using YieldBlox. So when you look at developing countries where most people don't actually have access to as much capital as people in rich countries do, those countries will be able to utilize YieldBlox to generate yield and use it as a savings product, where that would make no economic sense in the Ethereum ecosystem. And then also, finally, this is super exciting. YieldBlox will be able to support traditional assets like we talked about with OptionBlox. So you could take your DSTOQ Tesla and lend it in YieldBlox and then generate yield with that Tesla. And this is something that has never really been accessible for like capital markets users before, because you're going to be holding your assets in an exchange or a brokerage, and then they'll lend out your assets and take that yield. You don't have any access to that yield. So all of a sudden, you now can gain interest with your stocks because people will be borrowing them to trade on margin. And yeah, that's impossible.
Listen, everybody. Listen, everybody. Hold on. Understand what this young man is saying. This is impossible to do right now. This is impossible to do on any other protocol right now. We're talking about merging the two worlds between traditional finance, blockchain, crypto, stocks, you name it, gold, you name it, baseball card, you name it, NFTs, you name it. We're talking about combining all of that onto one platform. And this is just the beginning. This is insane, Marcus. And we're only starting. Nobody else is doing this right now. No, Stellar is not late to the game. It's called perfecting it. Shout out to Stellar Korea. Fred, I see you out there. Everybody in Korea, I love y'all, man. It is real late, and they're up listening to this. It's worldwide right now. We have over 100 people worldwide listening because this is really insane. This is what people have been waiting for. Once again, it's not called being late to the party. It's called perfecting it. You got any more for us, Marcus?
Yeah, I got one more slide. So we kind of covered this with OptionBlox, but this is the YieldBlox protocol overview. So users come into our website, they decide, hey, I want to lend Tesla, or hey, I want to lend Bitcoin. And then they ping our TSS protocol with that request. We then deposit that into a lending pool and send the user back a pool token, which represents their assets in that pool. So that pool token, it represents a portion of the ownership of the pool. So it actually increases in value as users pay in interest into the pool. So say Tyler comes in and says, I want to lend 100 Bitcoins to the pool. There are currently 1,000 Bitcoins in the pool. He will get pool tokens that say he owns 10% of the pool. So if Sam comes and borrows a bunch of Bitcoin, pays in fees, the number of Bitcoins in that pool goes up because he paid fees in. So now Tyler will get 10% of those fees because he owned 10% of the pool, right? So that's how we do interest.
Nice.
Users can lend in that way. Then other users can come in and submit a borrow request. They will then lock collateral in the protocol using a claimable balance. and then receive their borrowed assets. And then later on, they can go ahead and repay their assets, which will unlock their collateral. And then they'll also pay interest into the pool. And then finally, users can burn their pool tokens to unlock the underlying assets associated with those pool tokens. So Tyler can come in and burn his pool tokens that represent 10% of the Bitcoin pool, and he'll get back his initial 100 Bitcoin that he lent, plus any accrued interest.
Nice. And so what I'm seeing here is that it's utilizing, it's going to help to increase the liquidity of the DEX. Check. Is it going to affect demand and use of XLM in general? Check. What are some other possible usage outside of just financials? I mean, you mentioned carbon credits as one of them. You have any ideas of how else utilizing Turing's contracts and the way that you're showing here could be used?
Yeah, I actually have a pretty relevant one. In my day job, I work as a management consultant, and we do a lot of healthcare consulting. So health insurance is really interested in blockchain-based smart contracts because it's an absolute pain for them to track all their contracts and to make sure that they're executed correctly. So that's an area where I think Turing signing servers could be super valuable, because you have that shared data source with the Stellar blockchain, and then you can encode all your contract terms or your insurance terms into a Turing signing server TX function. So I think there are a lot of applications. Basically anywhere that you want to use a smart contract, you can probably make TX functions do it.
Nice, man. Look, time has gone by very quickly. I know we're on a time constraint. Markus, I appreciate you jumping on today. Tyler, so happy to have you here today. We learned a lot. We talked a lot about what you guys been working on. Tyler, Markus, any time frame to when we're gonna actually get to play around with products like this? Well, can you give us any time frame ideas?
I mean, from the TSS perspective, everybody go to tss.stellar.org, and you're going to kind of get to make that decision. You need to start setting up Turing signing servers so that we have a network. I think we just signed our 7th
nice
TSS, which is fantastic. That network has been growing quite a bit. So if you go to that page, we have a new reference implementation that's running on Cloudflare and AWS. So head over there and start setting up networks, or start setting up your Turing signing servers, and then just start making TX functions. I mean, it's all functional. It all works. We have the capability to do it right now.
Okay.
We just
You heard that?
People onboarding.
Nice. And maybe we can connect in the near future, Tyler. We can do a little video on showing people how to get one set up. I think that'll be a great way to get that information out there as well. Markus, I mean, he's saying it's ready to go. How soon until OptionBlox or Yield Blocks launches? What are we looking at?
We're hoping by winter of this year. We've got to do some final testing. We've got to get to do some final testing on Turing signing servers, but it's coming soon, and we're very excited about it.
Nice. A lot of great things going on this year. Markus, Tyler, thank you again for joining the show today. We learned a lot. Everybody at home that's been watching all over the globe, South Korea, Russia, Dominican Republic, everywhere, Ireland, Austria. Appreciate you guys joining in. I'm out. See you guys tomorrow, 12:30. We've got the man himself, Mike Kennedy, CEO, Velo Protocol. We're going to talk about some big things going on. This year might end up being an exciting one. Shout out to everybody. Thank you. Congrats coming in from Ivan. Congrats coming in from Crypto.G. Sam, Connor, Markus, Tyler, I'm out.
See y'all.